Welcome to the deep dive. Today we're looking at some really interesting stuff coming out of UC San Diego.
Hmm.
It's about a new way, a new technique that seems to offer much more, precise control over these large language models.
Yeah, the ones we're all starting to interact with more and more, like Google Gemini or OpenAI's ChatGPT.
Exactly. And they're everywhere now, aren't they? Helping with writing, translation?
Absolutely. Super powerful tools. But understanding how they actually get to their answers, that's been tough.
Right. And that lack of insight, well, it can sometimes lead to outputs that are, let's say, less than ideal.
Definitely. You get things that aren't quite right or sometimes even harmful.
So this new research, it's led by Professor Mikhail Belkin at UC San Diego. Seems like they might have found a way to sort of get under the hood.
And it looks significant. I mean, it's published in Science and Proceedings of the National Academy of Sciences,
Yeah, top-tier journals, that means serious peer review, fact-checking, the works.
which really tells you something. So, our mission today for this deep dive is to try and get our heads around this new method. They call it nonlinear feature learning.
Okay,
We want to explore how it actually works and maybe more importantly what it could mean for, the future of AI, making it more reliable, safer, better for you basically.
okay, let's dig in then. Before we get to the solution, what are the current problems, the limitations this research is tackling? We know they do amazing things, but where do they fall short?
Well, yeah, they're great at generating text, translating, answering questions, but their behavior isn't always predictable.
Predictable in what way?
It can show up in a few ways. Sometimes they just make things up. People call them hallucinations.
Ah, yes, the hallucinations. Tricky if you're relying on them for facts.
Very tricky. And then there are worries about bias creeping into the content or the model generating stuff that's, toxic or just unhelpful.
Okay, so that's the problem space. Now, the breakthrough, what exactly did Professor Belkin and his team figure out? You mentioned Daniel Biebelhol, Aditya Narayan, Radhakrishnan, and Rick Watsera were involved too.
That's right, a multi-institutional team. Their core idea is this nonlinear feature learning technique. Think of an LLM like a really complex recipe, maybe a cake.
Okay, like a cake?
Yeah. Instead of just tasting the final cake, this method lets them sort of identify the key ingredients, the flour, the sugar, the eggs, and understand how they contribute to the final taste and texture.
Ah, I see. So it's about understanding the underlying components, the features within the AI's network.
Exactly. These models learn countless features from all the data they process. This technique helps pinpoint the really important ones.
And once they pinpoint them,
Then they can start to, well, manipulate them, understand the AI's internal thought process better, as Professor Belkin put it.
understand the thought process. That sounds ambitious.
It is. But the goal is to predict and then actively influence the model, steer it towards helpful responses and away from the harmful stuff.
Okay, I'm following. But how? How do they actually do that? It sounds incredibly complex, almost like reading its mind.
Huh. Well, maybe not quite mind reading, but it's about gaining a much deeper level of interpretability than we've had before.
Interpretability. Okay.
So what they do is they look at the patterns of activity, the activations inside the LLM's different layers while it's working.
Like watching which parts of the brain light up.
Sort of, yeah. By analyzing these activation patterns across many examples, they can start to see links. Like this specific pattern often shows up when the model is about to say something factually wrong.
Okay.
Or maybe another pattern is associated with a certain writing style, or perhaps with toxic language.
Right. So once they've mapped these patterns, say the ones linked to making stuff up, what can they do? Can they just turn them off?
It's a bit more nuanced than an on-off switch. It's more like adjusting the volume. Once they know which features are linked to, say, hallucinations, they can gently tweak the model to rely less on those features.
And maybe boost the features linked to factual accuracy.
Precisely. It's about nudging the model's internal preferences, encouraging certain pathways and discouraging others.
Okay, that makes sense. Has this actually been tested? Like, have they shown it works?
Yes, definitely. They've applied it to some key areas and seen some really positive results.
Sish ass.
Well, significantly improving the model's ability to spot and avoid generating those hallucinations we talked about. That's a big one.
Huge. What else?
They also demonstrated they could reduce the model's tendency to produce harmful or toxic content.
Wow. Okay. Reducing hallucinations and toxicity, those are major hurdles for AI safety right now. Anything else?
Yeah, interestingly, they also found it could help the LLMs get better at understanding more nuanced language.
Nuanced language. Like what?
Things like Shakespearean English or even poetry. It suggests the technique might be tapping into a deeper level of semantic understanding, not just surface level text processing.
That is interesting. So it's not just about stopping the bad stuff. It could actually make the AI sort of smarter or more capable in subtle ways.
That seems to be the implication, yeah. It opens up possibilities beyond just safety controls.
So let's talk bigger picture then. What are the potential benefits here? If we have this kind of fine-grained control, what could that lead to down the line?
Well, one major potential benefit Professor Belkin mentioned is efficiency.
Efficiency. How so?
By focusing on these crucial internal features, they think it might be possible to fine-tune models effectively using less data and, importantly, less computing power.
Okay, less data, less compute. That sounds like it could make advanced AI cheaper.
Exactly. And potentially more accessible, not just something for the tech giants with massive server farms. It could, democratize things a bit.
That would be a significant shift, making powerful AI available more widely.
Definitely. And this ability to steer the models more precisely, it could pave the way for more tailored AI applications.
Tailored how? Give me an example.
Think about, say, an AI assistant designed specifically for giving accurate medical information. You'd really want to suppress hallucinations there.
Absolutely critical.
Or maybe a creative writing partner that's been fine-tuned to avoid generating cliches or harmful stereotypes. This level of control makes those specialized tools seem much more feasible.
I see. So more reliable, potentially more efficient, and allows for more specialized tools. What are the researchers themselves saying about the sort of overall significance?
Professor Belkin really stresses the potential for safer, more reliable, and adaptable AL. That seems to be the core motivation.
It makes sense.
And Rajesh Gupta, who's the interim dean for SCIDs at UC San Diego, called it a significant step towards building more reliable, trustworthy, and beneficial artificial intelligence for everyone.
So high hopes from the people involved. Are they keeping this technique to themselves?
No, quite the opposite, actually. They've made their code publicly available.
Oh, that's great. Why is that important?
Well, it means other researchers, developers, anyone interested can dive in, test it, build on it. It really speeds up progress in the field, especially for something as important as AI safety and control.
Right, encourages collaboration and further innovation.
Exactly. It's how science moves forward.
Okay, so just to kind of wrap up the main points, this nonlinear feature learning from UC San Diego. It's a new way to peek inside these complex LLMs. And by understanding and adjusting key internal features, we can get much better control over their outputs, make them safer, more reliable.
Yeah, less prone to errors like hallucinations or generating harmful stuff. It's moving from just training them and hoping for the best to actually actively guiding their behavior.
Steer them towards being more useful and, well, trustworthy.
Precisely. It's a really promising direction.
It really is. And, as AI gets woven more and more into the fabric of our lives, it does make you think. Well, having this kind of deep control, what are the ethical dimensions there? How does this ability to fine-tune the thoughts of an AI change our relationship with these machines and with information itself?
That's a deep question. It definitely brings up considerations about control, autonomy, and what we want these powerful tools to become.
Yeah. Something for you, the listener, to really chew on as we watch this technology continue to evolve at, well, breakneck speed.
It certainly is a lot to think about.